Design and testing. So the idea is when we make a piece of software, we want it to be the best piece of software that's going to have no errors and it's going to fully work every single time. So we have to try and reduce errors as much as possible by testing it, trying as many different tests as possible. We think about how the users might possibly misuse the program. So what errors are commonly going to happen with it. And how we maintain our code itself. So we should design it. The reason why we have comments in there is so that other people could improve our code or work with our code and maintain our code. Things like indentation, so everything's aligned with what's belonging to what. And variable names. If you call it A, B and C, that doesn't make much sense. Whereas profit or user, password, they're like variables that make sense. The problem with input. A program could work perfectly on its own and do the same calculation over and over again. So let's say it calculated if someone earned £200 a year, how much tax they'd have to pay. Okay, they probably wouldn't have to pay any because it wouldn't go past the threshold, but let's say it did. As soon as you start allowing people to enter things into the program, so the variables are based on a user input, that's when the programs can break. So input sanitization and input validation are the two main ways that we try and get around this. So input sanitization is where we take out any characters that we don't want to allow. So maybe we only let certain things be entered in. So it checks through. Usernames can't have any special characters in them, for example. Now the reason that usually is things like if you're trying to access a database that's sitting behind a website, typing in certain key commands can force the database to be deleted. So if we look at the SQL video, certain commands will delete from the database, so you need to protect your user input and allow them so they can't type in SQL commands. So that's an example of sanitization. Input validation is meeting a criteria. So you must have a username and a password of 8 characters. Okay, and if it's not 8 characters, then it won't let you have it. Testing. So there's two types of errors that we're looking for when we are testing a program: syntax and logical. And it can ask you this in the exam. They'll say, all right, look at line 14 in the code. Is this a syntax or is this a logical error? Okay. Syntax is when the compiler doesn't recognize the language you type. So a syntax error would be, let's say we're writing an English essay and you suddenly start talking German. Now, you wouldn't understand, you wouldn't expect that to be there. So that's a syntax error. So syntax is the rules of a language. So let's say in English, we're using this as another example. When you start a sentence, you have a capital letter. Use a full stop at the end. That's the syntax of the English language. Often what happens is when people are programming, they misput an indent or they don't put a comma at the end. And those things break the program because the program says, well, these are the rules that I want you to use and you're not using them properly. A logical error is when the program will run but it behaves unexpectedly. So if less than 16 provide alcohol, that would be that's a logical error. Okay. So although the program runs itself, logically it's incorrect. The logic on it is wrong. If it's raining, put umbrella down. Logically that's wrong. You want the umbrella to go up. There's 4 common types of tests that we can carry out. So performance is how quick the features run. Okay, so we look at the effect on the CPU. So we run the program and then we look under the bonnet and see, well, how much drain is that taking on memory? How much drain is it taking on the processor? Is it making, is it increasing the heat? What's the performance of the computer doing? Usability is how user-friendly the software is. So you might say, get different target audiences to try your software out. An expert user or somebody who's a bit of a novice. Child, an elderly person, you get different people to try it out, and how usable is your software. Security is how vulnerable the software is. So we might try and do some white hat hacking where you're trying to break in to see if any errors happen. Okay, because if your software isn't secure, you need to know that. And Facebook actually apparently run a competition every month where they try and break in and test out the security because it needs to be secure. Load and stress test. How does it work with lots of users at the same time? Let's say you've made a new operating system or you've made a program. If everyone's got that program open, what happens? Does it go down? Does it stay working? So that's a stress test. And finally, we've got a test plan. Now, we did these in our coursework. This is a slightly different example to it. It's less detailed than what you did. But when you are testing it, you should have a plan, because usually you have to provide documentation. If you're selling the software, you want to prove that it has been tested. So the type of data, first of all, put some valid data through it. What is the test data that's been put in? Password. The reason for testing it, see if the program logs in okay, and expected outcome is that it should let us log in. If we tried just valid data, it'd be a pretty useless test because it wouldn't cover the whole of the program. And the idea is to try to cover the whole program. So we'll put some erroneous data in, see what happens with that. Okay, so the test data this time has got the @ symbol or ampersand, and the reason for testing is to see if the program allows misspelled password, expected outcome, error in the password.